Now the next piece is a surge relief. Now we have to worry about water hammer. You know, if we fill this line really fast, we're going to send water down that pipe really fast, and how we get water hammer is by excessive velocity in the water, by letting it flow too fast down the pipe. Now as it's flowing down the pipe, it doesn't have a problem. When it has a problem is as it's flowing down this pipe, when it hits the end of this pipe. And it's running down this pipe and boom, it hits the end of that pipe. And all that energy has to go somewhere. It's like a car running into a wall. You know, something happens. Well, the car gets crushed if the wall's stout enough, or the wall and the car both get damaged. Or two cars run into each other. You run into a parked car, they both get damaged. Well, in this case, you know what we're afraid of is we're afraid we're going to blow the pipe out of the ground, and it can happen. You know, you're not going to hurt the water any. You're just going to compress it a little bit. But as we're running down a pipeline, and we have that water hit the end of that pipeline, and we're just filling it full bore, when it hits the end here, all of a sudden it has to release that energy. Well, the release of that energy is called water hammer. And what it does is it sends a shock wave right back. There's a force shock wave that just goes right back down the pipe. And you can calculate how many total pounds of force that is by knowing the velocity and knowing the size of the pipe. You can actually calculate just how much you're actually running into. So we're developing water hammer. You've probably all heard that in piping systems in a house. Like probably the biggest culprit would be a washing machine valve. They turn off very fast. And when the washing machine's running and a valve turns off real fast, you hear the pipe go ping, ping, ping inside your house, or you hear them rattling inside your house. That's water hammer. At a very small pipe, under a reasonably low pressure, but you can hear that effect occurring within the system in your house. Well, to counter this, we need to be able to bleed off this surge when it hits the end of the line. Well, the simplest way is to have knowledge of the system so that when you operate it, you fill the line slowly and never allow it to happen. But what if it does happen? What if somebody opens the valve real fast at the front end of an empty line? You're going to create a water hammer. You're going to create a surge. Not necessarily water hammer. You're going to create a surge. We can then do something to take away the surge. And that is put in a surge relief. And so the most common place to do that is down here, wherever the pressure gets highest in the line or at the end of the line. So out here, we would apply a surge relief valve. Got an example of a surge relief valve we might put out on a valved main line like we'd use in wheel line and hand line, or at a pivot point. Just threads on to a standard riser, threaded riser. We just put an extra T in riser in the line at the highest pressure point, which would be the lowest point in the line or the end of the line, or both places, wherever we might have a surge pressure. We will install one of these, and all it's doing is keeping a valve cap down. Now what keeps the valve cap in place? This great big heavy spring that's sitting right here. And we set the tension on that spring. All I have to do is tighten the spring by tightening down this nut. As I tighten the nut down clockwise, it compresses the spring and takes more pressure to pop the thing open. If I do just the opposite, if I take tension off, it takes less pressure to push this thing off the seat. So we can adjust this to the safety limit we want on the main line. If we're running hand line or wheel line and we have 50 psi on the system or 60 psi on the system, we might set this to raise off when the pressure gets to 80 psi. So it's when it gets to 80 psi, the pressure starts to overcome the spring tension, and it starts to lift off its seat, and water starts to flower out. So if we open the valve real fast and send a surge of water down, when it hits the end of the line, this valve will go poof, pop up and blow water out. Or if the pressure builds too great, if we shut all the lines off on the line and the pump keeps running and it builds too high a pressure, this thing will just start lifting off and releasing that added pressure. Now true, it's going to make a mess. You're going to get a whole bunch of water right there, but you're protecting the line and you're not going to blow the line up. So that's the value of surge relief.